right, this is a quick little video to show you how to run a one sample t-test and tell whether it's statistically significant and look at the effect size. So I've opened up JASP and I'm going to open up data that I call final exam data. This isn't for our final exam, this is for another class that I taught, 52 actually, so if you're going to take 52 with me, you might see this data again. I created a longitudinal data set looking at how much students love statistics at 3 points during the quarter. And for our one sample t-test, we are just going to look at how much they love statistics at the first time I measured it. So we go to t-test and click on it. And in the classical t-test, we hit one sample t-test. And we're just, as I said, going to look at stats love 1. This is how much students love statistics the first time that we measured it at the beginning of the quarter. So right away when we put that in here, we get a one sample t-test, and it gives us a t-value, and it gives us degrees of freedom of 59. There were 60 cases, so the degrees of freedom would be 1 minus that, and a p-value. But it's comparing the average love of statistics in this sample at time 1 against the test value, which it just puts in as 0. We don't want to test our sample mean against a test value of 0 because we don't think in the population, this is going to be the mean for the population, we don't think that it's going to be 0. So let's get an idea of what we think it might be. Now, keep in mind, we're just making this up. We don't know what the actual population mean will be. So if we hit descriptives, this is for our sample. In our sample, the average love of statistics is 4.933. So now we say, okay, let's just suppose that in the population, the average love of statistics was actually something like 4.50. So you would need to enter in a value here where the test value goes. And it should be something a little bit above or a little bit below your sample mean to have kind of a reasonable comparison. When we did that, it changed our t-value, made it much smaller, and it changed our p-value. So here's what we know. The p-value is the probability of getting a sample mean this different from the population mean by chance. And the probability of getting this difference between the sample mean and the population mean of this size by chance is 0.034. So about 3 times out of 100 is what you would, how often you would expect to get a sample mean this different from the population mean by chance. In psychology, when the p-value is smaller than 0.05, we generally consider it statistically significant or a meaningful difference. This value of 0.03 is smaller than 0.05, which means we would consider this to be a statistically significant difference. We would say that our sample mean is significantly higher than our population mean, assuming that this here is our population mean. So that's how you interpret the p-value. And then for an effect size, you would click on this box here that says effect size, and it brings up a Cohen's d. This Cohen's d is 0.28. We said in the book that a Cohen's d of 0.2 or less would be considered a small effect size, and like between 0.2 and 0.5 would be considered a medium effect size. This would be a small to medium effect size. So that's how you would interpret this Cohen's d. There's a little bit of practical significance, not a lot. So that's a quick demonstration of how to run a one sample t-test in JASP and how to tell whether it's statistically significant and what the effect size is. I hope that's helpful.